Good afternoon, everybody. Good morning, everybody, and good evening, everybody, depending on which time zone you're in. I hope you can see my screen. My name's Simon Boyde. I'm the chair of IWI's Low Impact Navigation Group. This group originally focused on electric propulsion for inland waterways vessels, which looks like an obvious thing to roll out. But this is not necessarily something which can be done for all vessels or all waterways, and the size of the budget required to do it may prove prohibitive. No one really has true figures at the moment. So what we've been concentrating on in the low impact navigation group is methods by which we can actually reduce the amount of energy needed to propel a boat. And once we've got the boat to be efficient, we can actually look at how we might get the energy to push that boat down the waterway. So I'm talking about low impact boating. So what we're doing here is we're talking about reducing the impact we and our boats have on the inland waterways and on the environment. So I use engineering rule number 1 here. Don't use the energy in the first place. If you don't use the energy in the first place, you don't need to replace the energy. You don't need to burn fossil fuels. You don't need to buy extra solar panels because you haven't actually used it in the first place. So what do we need to do? Well, I'm a naval architect, and for most waterways, most inland waterways, which are canal-based or river-based, except for the very largest, we normally have speed limits on the waterways. We'll have vessels which are constrained by draft. We have quite a lot of low draft on canals, or beam, or air draft. So we need to be focusing on our boats needing to go slow and how do we make those boats efficient. Trips generally are measured in hours or days, not miles or kilometers. If we're on a leisure trip, we pop down to the boat for an afternoon or for a weekend. We don't pop down the boat for a 20 miles or a 30 kilometers. The industry currently sells speed, but this makes little sense for inland waterways. Obviously, if we're going to make a boat efficient, we need to focus on getting the hull form to be as low drag as possible. There's no point wasting energy pushing a square box down a waterway. Together with getting the hull form efficient, we should make sure our propulsion system is as efficient as possible. Inevitably, if we don't have electric sources round, charging points around a canal network, and we certainly do not have that anywhere at the moment, we're going to have hybrid drives of some form with alternate power sources to offset the amount which internal combustion engine will run for. We must make sure we're using the most efficient electrical system we can. We have to look at charge-discharge cycles for batteries to be as efficient as possible. We have to make sure our heating and cooling is as efficient as possible. So this means heat pumps on board boats. We need to focus on CO2 emissions. This is not just for propulsion or heating or cooling, but this also means for cooking. And with our hull designs, we should focus on how we can make sure we don't damage the canal sides, the canal bottom, and other parts of the canal infrastructure, because obviously if we damage it, we have to repair it. So my company, Canals, we spent 8 years developing a new form of narrowboat for the UK inland waterways. Now, narrowboats are a very curious thing. They're limited to 70 foot, about 22 meters long, 7-foot beam, about 2.1 meters, and a draft probably of a maximum of 1 meter, and an air draft of only about 1.8 meters. It's probably the tightest box of any of the waterway systems. There are similar waterways in the Netherlands. South of France, the Canal du Midi has limited draft, and I'm very aware that in the US, even with its big canal systems, there's still sequences of waterways with quite low speed limits. We built 4 models of a boat and tested them, and we basically came up with these results. We placed a pressure sensor underneath our model canal there, and we monitored just how much energy was dissipated by each of the propulsion systems as the boat crosses over the pressure sensor. And we built the best one, which is the C150 type, which you see here. And that's a photograph of the completed hull. We basically focused on trying to make canal boats typically have a flat bottom, of course, so that when the canal gets a breach, the boat can take the bottom without falling over. But we narrowed our base plate. We have about a 50% reduction in base plate area. And this, of course, reduces the limits on the return flow, which otherwise causes squat. That squat, whether you've got stern trim or bow trim down on a hull, will suck down the end of the hull which is closest to the bottom. Normally on inland waterways boats, this is the stern. And that, of course, increases drag dramatically because, especially in low water conditions, we'll actually have the hull of that boat in the mud at the bottom of the canal. So getting level trim on the boats was something which we really focused on in this design. And we also looked at propulsive efficiency. Now, typically, most engines are put in leisure marine boats with a standard diesel engine will put in with a 2-to-1 reduction gearbox. In reality, we need to be running the prop as slow as possible. So the largest prop running as slow as possible gives our biggest efficiency. We may not do this in a sailing boat at sea because we want a small prop which doesn't cause drag. We may not do this on a boat which planes because we want to be able to lift the boat out of the water. So we don't want to have a large prop keeping more of our hull immersed. But on an inland waterways boat, which is a displacement boat, the biggest prop we can get is the best large reduction gearboxes. The prop can see more of the water. There's less hull obscuring the prop going forward. That reduced prop wash results in much lower canal damage, erosion to the bottom and the sides of the canal as we go down the canal. We really focused on reduced CO2 emissions with this design. So the boat's fundamentally an electrically driven boat. We have a parallel hybrid setup by which we can drive it with an electric motor or a diesel engine. The reason for that is that we designed this boat to have 2 modes. It's designed to have a canal mode. There's no current on the canals, an electric motor is sufficient to drive it. But we also want to be able to tackle tidal waterways. Tidal waterways have tidal currents. 4 or 5 knots is typical in waterways around the UK. And obviously a lot more wind is possible when you're in estuarine waters or on lakes. And we can get quite a lot of wash and waves from fast-going ferry boats and commercial craft. So having a high power mode, which we can use in those tidal waters, even though the majority of the time the boat would be running much, much slower than that on canal waters, meant the parallel hybrid option is best for this boat. A different user of a boat might only need a low power mode, in which case a single engine style, so a single electric motor with a generator, a serial hybrid setup would work just as well. Self-evidently, that diesel engine could be replaced by a fuel cell system. At the moment, there is no practical small fuel cell available for a boat, for an inland waterways boat, so the size of 1 to 2 kilowatts, which is what we would actually need. I have seen one advertised. Prices are down to only about triple diesel engines now, but they have not been marinized yet. And the word from the guys who are running some tests on fuel cells on an inland waterways boat in the UK was make no plans for them to be commercially available yet. The test has not been going well. We can always take a conventional diesel engine, and I know of no diesel engines, small diesel engines, which we cannot use with HVO fuel. HVO fuel is fully sourced from renewable sources. A lot of it is made from waste vegetable oil, which has been used for cooking or for other purposes. It does have a much higher cost of production, but because we've made our boat much more efficient, our actual cost of running the boat is not higher, even if we have purchased HVO fuel. It's considered that HVO fuel reduces CO2 emissions of a vessel by 90% over conventional diesel. Obviously, we still have oils, we still have transport costs to get that fuel to us, so we can't say it's a zero emission fuel, but we're getting much closer to that net zero position, which the IMO has us all aiming for by 2050. I touched in the introduction on advanced cycle efficiency. So a lot of people putting electric boats in, they're using lead acid batteries or variations to lead acid battery, lead carbon, AGM batteries, whatever. But I strongly recommend that people who are putting a boat together go with lithium batteries, a round trip efficiency. So the energy which we've got put into charging the battery, by the time we've taken it out and want to put it into an inverter for AC power or into an electric motor for propulsion, we've lost 80%. If we do this with the lead acid battery on the lithium battery, we've lost nearer 20% of the power. So we get a much higher round trip efficiency with lithium ion batteries. And over the life of a lithium ion battery, they are cheaper than a lead acid battery anyway. For the boat which I built, our prototype boat, we don't expect to ever replace the batteries on board. We think the batteries will last as long as the hull, more than 30 years. We must try and make sure that everything else which we're using on the boat is as efficient as possible. So not a normal electric cooker, but an induction cooker. We're using a DC refrigeration where we can. There's no gas on board, there's no diesel heating, there's no solid fuel stove, there's no particulate emissions except from the motor. And our AC conversion rates are very high efficiency, over 95%, all lighting on board LED, of course. Then our heating and cooling. Normally we can't use a heat pump system too successfully inland waterways, because the problem is unlike seawater, which in winter barely freezes, it's got to get very cold. Freshwater, of course, will freeze at 0 degrees. Now, we get a layer of ice outside the boat with liquid water underneath, which we can use as a heat source from our heat pump to heat the boat. But when the system's off, it would have fresh water inside the system, which would freeze, because the system inside the boat is in air. In order, therefore, to avoid this, is we have to have an internal heat loop and an external heat loop. And we don't actually pump canal water or river water through our heat pump heat exchanger. Instead, our design has a special hull integrated heat exchanger. In the US, these external heat exchangers are very, very common and are used on most of the commercial craft on the big rivers in the US, mainly for engine cooling, but I know some are also used for heat pump installations as well. On the UK canals and, for example, the lower French canals like the Canal du Midi, this would not be the right thing to do because our boats hit the banks, hit the bottom all the time because we are very constrained with draft. Because we have no open flame devices on board the boat, we can cut ventilation down to minimum required for human life because we don't have to have any fear about carbon monoxide poisoning. That reduction in ventilation means we take less heat out of the boat in terms of hot air being sent out of the boat. We also take waste heat from the engine, and we use that for heating domestic water, which is very common, but we also take waste heat and pump it in around the boat to offset the amount of time our heat pump has to work for. Then we're actually looking at the full life cycle of the boat, and we're looking at what we could possibly build a boat out of. Now, steel is the best material for displacement boats because the CO2 production cost of steel and GRP is very similar. But at the end of life of your steel boat, it is almost certain that more than 90%, and probably near 100% of the steel at that boat is commercially recoverable. We already know how to recycle steel. It's highly recyclable. It is thought that 70% of steel ever produced, and steel has been in production now in the world for over 2,000 years, 70% of steel ever produced is still in use because it gets reused so many times. It's very much a closed loop recycling material. We can take old steel and we can reforge it and create new steel out of it, which has the same properties as the old steel. Something very difficult to do with aluminium and impossible to do with fiberglass. Current fiberglass recycling, generally the favored route is to convert it into a powder which can make concrete weaker. We can't use that fiberglass in fiberglass again. Then interior materials, we should use recyclable or at least biodegradable materials. Wood, of course, wood interiors. HVO fuel for the diesel engine, as already mentioned, cuts down our greenhouse gas emissions to zero or net zero. This is available in dozens of marinas in the UK. A similar fuel is being pushed in France, but it's a B100 fuel, so a FAME-based fuel, not very good for marine engines. But HVO fuel is available there, but not in so many places. HVO is commonly available throughout the Netherlands. I've seen it on sale in Italy as well. And I've read articles saying it's available in the US. So we know it's there. You can get to net zero pretty much. With our design, we've made sure that our systems are compatible with future fuel cells. My problem with fuel cells is I've been told since the 1970s that workable, cost-effective fuel cells are 5 years away. And that was said in 1970, and it was said last year, and I still can't buy one. I'm still looking forward to them being available. We end up with this hull design much reduced CO2 emissions for propulsion, for heating, for cooking, and for construction. We can take a lot of lessons for this, and we can utilize these lessons in existing boats as well. Existing boats could use HVO fuel. Existing boats can be properly insulated. Why hybrid? Well, a plug-in electric boat sounds wonderful, but the electricity you use to recharge that boat is as green as the national production of electricity unless you actually have a completely isolated source. So in France, in a good year, 70% of the power comes from nuclear, so it is indeed a zero CO2 emitting fuel. But in Germany, for example, last year, 60% of the electricity came from coal, and this is not a zero producing fuel. So we have to be cautious about plug-in electric boats as being the only solution we should consider. Because until national grids are all changed over to net zero, the electricity from them can't be considered to be that. The other problem we have with leisure marine boats is they spend most of their time not moving. The average boat, after all, is used, inland waterways boat in the UK, is used for 5-6 weeks a year. About triple the rate of a seagoing leisure marine boat, it has to be said. But most of the time they aren't moving. So putting in lots of recharge stations around the network, when frankly most of those recharge stations only be used for 4 months of the year, means it's unlikely to ever be practical to provide sufficient charge points. Solar-only boats, I had a customer looking for one of those, and he wouldn't accept my argument that the boat had to be about 18 feet wide, difficult to get into a 7-foot wide lock. The solar panels simply don't have that power density, and in any case, for 4 months of the year, the sun is so low in the sky that we don't get any effect from that. Hybrid hire boats can be rented out as a premium, and Alfred, who will be giving the talk after me, will be talking about a plug-in electric boat on a limited route in France, which has been set up, and definitely this is something which the market is looking for, but difficult, where it may be possible for hire boats on fixed routes, be very difficult to translate this into the open cruising system which the UK has and many other countries have available on their inland waterways, simply because the number of charging points that would be required. So, the low impact boat. What can we do now to reduce the environmental impact of our boats? Make sure your hull, you're buying a new boat, is an efficient hull, and the boat is designed to reduce the energy consumed. Use all alternate power sources where possible, which means solar or wind if you're in a windy place. When you're using your diesel engine, please use HVO fuel. Please make sure you're charging from that diesel engine to your electric battery bank is as efficient as possible. A really big alternator massively means that we cut down those engine running hours. Use lithium batteries to reduce cycle losses. Focus on closed-loop recyclability of materials used in construction, so steel is your friend. Insulate the boat, and then insulate it again, and then buy double glazing or triple glazing. Reduce pollution. Bilge water filters, we fit those as standard. Grease traps are a very good idea to put in. Grey water filtration systems are mandatory now on some waterways. We've made sure in our designs that such a grey water trap system is possible. Slow boats. Fast boats need more energy to cover the same distance. When we go on a 2-week trip, we don't do a 200-mile trip. We're doing a 2-week trip. Why do we have to go fast? And the last thing I'll leave you with is long fin boats are inherently more energy efficient than short boats. They have a much lower frontal area. Unfortunately, in many parts of the world, licensing for inland waterways boats is based solely on length. We should actually try to make sure that we encourage long, thin boats, in which case we need to change our licensing fees to be the product of beam times length, so the area, maximum area the boat takes up, not in terms of just length, because this means that we no longer are taxing the boat to be long. We're encouraging the boat to be any shape you like, and generally then the market goes to the most efficient shape. At the moment, we're taxing it and we're persuading people that short, fat boats are better, when in fact they're not. I'm done. Thank you very much.
WCC Online is brought to you by Inland Waterways International, better known as IWI, TICI, the International Committee for the Conservation of Industrial Heritage, and the Society for Industrial Archaeology.